This object was targeting the inner solar system.
These objects do not do that. These objects can go against the direction of the wind.
Something just entered our solar system that shouldn't exist. 3I Atlas, our third interstellar visitor, is an 8-kilometer cosmic boulder flying through space at 60 kilometers per second. But here's what has astronomers panicking. It's changing course in ways that gravity and gas jets simply can't explain. What invisible force is rewriting the laws of physics right in front of humanity's best instruments? The answer might change everything we thought we knew about the universe. July 1st, 2025. The Atlas survey spots something moving impossibly fast through our solar system nearly 60 kilometers per second. That's twice the speed of our previous interstellar visitors, and fast enough to escape the sun's gravity forever. Within hours, observatories worldwide confirm the unthinkable. This isn't just fast, it's massive. Between 3 and 7 kilometers across, 3I Atlas dwarfs every interstellar object we've ever tracked. For perspective, that's comparable to Halley's Comet, except this giant came from another star system entirely. With an eccentricity over 6, Atlas is following a nearly straight line through our solar system, a geometry so rare it makes seasoned astronomers pause. But as 3I Atlas barrels toward the inner planets, something impossible begins to happen. Its path starts to veer. Before we dive into the impossible, let's talk about the rules 3I Atlas is breaking. For centuries, astronomers have understood comets as cosmic dirty snowballs, mixtures of ice, rock, and dust, held together by gravity. Picture a balloon releasing air. As a comet approaches the sun, solar heat vaporizes its icy surface, creating jets of gas and dust that act like tiny thrusters. The European Space Agency's Rosetta mission to Comet 67P showed us exactly how this works. Jets powerful enough to change the comet's spin and slightly alter its orbit. The physics is elegant and reliable. More heat means more outgassing. More outgassing means more thrust. This is the rulebook that has governed every comet we've ever observed. The same mathematics that guided Voyager to the outer planets and helps us track potentially dangerous asteroids. 3I Atlas is about to tear that rulebook apart. Orbital prediction should be a solved problem. Feed the data into our equations. Mass, velocity, solar gravity, planetary tugs, and any object's path should trace out with mathematical precision. For 3I Atlas, the math is failing catastrophically. Picture hundreds of the world's best telescopes, from Mount Wilson to La Silla, all tracking the same target. Each telescope captures timestamps, coordinates, and margins of error. Stack these measurements together, and a pattern should emerge, one that matches our equations perfectly. Instead, something goes wrong in the overlay. When astronomers predict where an object should appear and then observe where it actually shows up, any tiny differences are called residuals. For normal objects, these gaps scatter randomly around zero, just natural noise from measurement errors and atmospheric distortion. 3I Atlas produces residuals that drift systematically, building into a pattern that persists across datasets and observatories worldwide. Multiple independent teams confirm the same impossible result. This isn't bad data or equipment failure. It's a real signal that our physics is incomplete. Instead of random scatter around the predicted position, the actual observations form a trail that veers consistently away from theory. For the first time in centuries, the orbit itself has become the main character, refusing to follow the script that has governed celestial mechanics since Newton. The James Webb Space Telescope reveals 3I Atlas's most shocking secret. Its chemical fingerprint is unlike anything in our solar system. While most comets are water-dominated, Atlas spews carbon dioxide at an 8-to-1 ratio compared to water. That's completely off the charts, even compared to the weirdest Oort cloud visitors. Carbon dioxide pours off the nucleus at rates of 129 kilograms per second, while water manages only 6.6 kilograms per second. The Very Large Telescope's spectroscopy reveals something even stranger, and 22 distinct emission lines from atomic nickel. But iron is nowhere to be found. This violates everything we know about cosmic chemistry. Nickel and iron are forged together in supernovae and should travel as a pair through interstellar space. Here, nickel is streaming into space without its usual partner, suggesting breakdown of exotic organic metallic complexes that traditional solar system chemistry has never produced. Here's the killer paradox. All this outgassing should create massive thrust, like a cosmic rocket engine firing at full power. With 129 kilograms of gas escaping every second, the force should easily explain Atlas's trajectory changes. But when orbital modelers plug in these numbers, they don't add up, not even close. This is where the story becomes genuinely terrifying for astronomers. 3. I-Atlas isn't some pebble drifting through space. It's a cosmic mountain with billions of tons of inertia. Mass estimates put the nucleus at several billion tons, thousands of times more massive than Oumuamua. To nudge something this massive off course requires forces that dwarf what normal comets ever experience. Think of it this way. Imagine trying to deflect a freight train with ping pong balls. Every molecule of gas Atlas throws off barely registers against its enormous bulk. The Rosetta mission showed that jets on Comet 67P could move a mountain-sized chunk by a few kilometers per orbit. But Atlas is in a completely different weight class. It's like comparing a bowling ball to a grain of sand. Here's the nuclear scale paradox that's keeping physicists awake at night. The observed trajectory changes require sustained force over months, not brief bursts, but continuous acceleration. Calculate the total energy needed to shift Atlas from its predicted path to its actual position, and you're looking at the equivalent of a small nuclear explosion spread out over time. Yet all the measured sources, gas, jets, dust, ejection, solar radiation pressure, add up to less than 1% of that energy budget. Even if the entire surface erupted simultaneously, it still wouldn't supply enough push to account for what we're observing. The momentum budget comes up completely empty. The math demands an explanation that current physics simply doesn't have. Every conventional explanation gets stress-tested and comes up devastatingly short, hidden fragmentation. There's no evidence for a major breakup, no sudden brightening, no debris trail spreading behind the object as it moves away from the sundae. Loose rubble pile? The steady, consistent outgassing suggests a coherent body, not a crumbling aggregate. The chemical signatures point to organized internal structure, not loose debris. Exotic internal energy, radioactive decay from isotopes forged in Atlas's birth star, could generate heat and pressure that drives outgassing in unprecedented ways. This is plausible for explaining the exotic chemistry, but still doesn't bridge the momentum gap. Every door leads to the same conclusion. We're dealing with forces or phenomena that lie completely outside our current theoretical frameworks. The implications extend far beyond one mysterious object, reaching into the foundations of everything we think we know about space. Planetary defense systems rely on the exact same mathematical tools that are failing catastrophically. With 3I Atlas, when astronomers spot potentially hazardous asteroids, they use identical trajectory calculations to determine Earth impact risks. If these fundamental equations can be wrong about something this basic, how much can we really trust our ability to predict the next cosmic threat? What if a future asteroid behaves like Atlas, shifting course in ways our models never anticipated? 3I Atlas is forcing us to confront an unsettling truth. Interstellar space might operate under completely different rules than our solar system. For 4.5 billion years, every object in our cosmic neighborhood has been shaped by the same star, the same gravitational environment, the same chemical processes. Visitors from other star systems carry fingerprints of alien suns, alien chemistry, maybe even alien physics that our Earth-based experience never prepared us to understand. 6 years ago, a 400-meter object called Oumuamua shot through our solar system and left scientists equally baffled. Despite showing no visible jets or coma, it accelerated mysteriously 17 millimeters per second squared, as if nudged by an invisible hand. Now 3i Atlas is showing the same rule-breaking behavior, but at a scale that makes Oumuamua's mystery look trivial. We're not talking about a tiny rock drifting slightly off course. We're watching a cosmic mountain defy the fundamental equations that govern how matter moves through space. What started as a one-off curiosity is becoming a genuinely disturbing pattern. Interstellar visitors consistently behave in ways that local physics can't explain. The astronomical community is in full crisis mode. At NASA's Jet Propulsion Laboratory, mission planners who successfully navigated spacecraft to Jupiter and beyond are staring at equations that simply won't balance. Dr. Alan Fitzsimmons from Queen's University Belfast, a veteran comet observer who has tracked dozens of these objects over 3 decades, puts it bluntly: the standard models that have never failed before are producing residuals that shouldn't exist. Emergency observing sessions are being scheduled at major observatories worldwide. Telescope time, normally reserved months in advance, is suddenly redirected to track this single object. Meanwhile, Harvard's Avi Loeb argues that when conventional explanations systematically fail, the scientific method demands considering unconventional possibilities. Whether that means exotic physics or something more radical, Loeb contends that ruling out possibilities before gathering sufficient data violates the principles that drive discovery. When every conventional door slams shut, science is forced to peer into territories that sound like science fiction. Some researchers wonder if Atlas interacts with dark matter streams invisible to our instruments. Maybe it's wrapped in materials that respond to electromagnetic fields in ways terrestrial physics has never encountered. Harvard's Avi Loeb has suggested even more speculative possibilities. What if some interstellar objects utilize ultralight sail structures designed to catch starlight like cosmic parachutes? The numbers work for small objects like Oumuamua. For Atlas, with its enormous bulk, the mathematics becomes more challenging but not impossible if the object is hollow or engineered for maximum surface area. No one in the mainstream is calling Atlas artificial, but the fact that these ideas are even being discussed shows how far this object is pushing our boundaries. When gas jets can't explain the motion, when every natural force falls short by orders of magnitude, physics demands another answer, natural or otherwise. Maybe 3i Atlas represents natural technology, complex organization that emerged under conditions we've never imagined. Maybe it's evidence that the universe holds secrets about matter and energy that could revolutionize our understanding of reality itself. The Vera Rubin Observatory, with its 10-year legacy survey of space and time, is about to flood us with discoveries. When Rubin comes online, astronomers expect to detect dozens of interstellar objects every year, maybe hundreds. 3i Atlas isn't a once-in-a-lifetime event. It's the beginning of a cosmic deluge. For the first time in human history, we'll have a steady stream of messengers from other star systems. But here's the catch that keeps astronomers awake at night. If our fundamental models can't handle Atlas, what are we missing from the objects that slip by undetected? 3i Atlas has proven that gas alone cannot explain how massive interstellar objects move through space. Despite extraordinary outgassing at 129 kilograms per second, despite exotic chemistry unlike anything in our solar system, despite the combined efforts of humanity's most advanced instruments, the fundamental question remains unanswered. What invisible force is reshaping the path of this cosmic visitor? The mathematics demand an explanation that current physics doesn't provide. This isn't just about one object defying gravity. It's about the limits of human knowledge when confronted with messengers from deep space. Is this natural physics we haven't discovered yet? Or something more radical? What if these messengers from other stars carry not just exotic chemistry, but evidence of intelligence operating on scales we're only beginning to comprehend. The universe is vast, ancient, and filled with processes that dwarf human experience. 3. Atlas reminds us that we're still beginners in the cosmic classroom, still learning the most basic lessons about what travels between the stars. Picture the moment when the next interstellar visitor appears on our telescopes. Will it follow the same impossible pattern as Atlas and Oumuamua? Will it reveal the missing piece of physics that explains how these objects really move? Or will it deepen the mystery even further? What do you think 3I Atlas really represents? Natural phenomenon, pushing the boundaries of known physics, or evidence of organization and intelligence in forms we're only beginning to imagine? Let us know in the comments below. The next chapter in this story is already racing toward us from the darkness beyond our solar system, moving at speeds that will bring it into view sooner than we expect. Each new detection brings us closer to understanding whether we're alone in our corner of the galaxy or whether we've been quietly receiving visitors all along. If you want to be there when the universe reveals its next impossible secret, make sure you're subscribed, because the answer might rewrite everything we thought we knew about physics, chemistry, and our place in the cosmic order. The mystery of 3I Atlas is just beginning, and the universe isn't done surprising us yet.